All right, so we're looking at the worksheet on 5.8, and then do you have a preference on 11 through 14?
Not really. Yeah, I mean, they were all
Okay,
similar. Like,
well then I'll just do 14, because that one is some different numbers from some of the other numbers we've looked at so far. All right, so in 14, if you are going to work an arctangent problem that also is asking you to look up cosecant, the reason it's listed this way is because arctangent can help you draw the picture, and then on the picture you can look up cosecant. So since tangent's negative in quadrant 4, we can just draw a triangle down there in quadrant 4, because that's where tangent can be if it's negative. It can't be in anything else, because tangent only uses quadrant 1 and 2. And because the formula for tangent is y over x, are the y's in that quadrant negative? Then my negative's in the right place. You got to be real careful about that, because sometimes the negative gets moved up when they're flipped, and maybe when there's some of the other words, and you might have to move the negative back down. So you always need to check to see which number really should be negative, because we always move negatives up. But in this case, the y is negative. It's y equals negative 5 and x equals 12. And we need r in order to be able to do cosecant. And so we do Pythagorean theorem, 5 squared plus 12 squared equals r squared. And it doesn't matter which one I put, a or b, because it's x and y and they're interchangeable in the formula. And that comes out to be 13. Because I just happen to know 5, 12, and 13 is one of those Pythagorean triples. Once you do that, then you're ready to work the cosecant of this angle that's up here in the corner next to the origin. And cosecant is the reciprocal of sine. So if I find sine, I just flip it. So sine is always y over r. So cosecant is going to be r over y. And I'm going to put 13 for r and negative 5 for y. And that's where I was talking about before. We never leave negatives on the bottom, so I'm going to move it up. So if they had given me the cosecant to draw the picture with, I'd have had to move that negative back down, because it can't be on r. R is never negative. But in the answer for the final question, you always move your negatives up. All right. How do we feel about that particular section? Think you need to go and try some more of those and see if you can draw your own pictures? Just remember that it is very, very specific. Cosine uses 1 and 2. That means secant would use 1 and 2. Sine and tangent use 1 and 4. So that's why cosecant could use 4 also. But cotangent doesn't do what he's supposed to do. He should use what tangent's doing, but he doesn't. And let me explain that in case you happen to run into one about cotangent. See, cotangent is cosine over sine, right? And tangent is sine over cosine. And because of that, because they have that relationship, when you're doing tangent, it uses the same quadrant on what's on top. And so cotangent uses the same as what's on top. And so they don't use the same quadrant that each other use. Sine and cosecant use the same thing. Cosine and secant use the same thing. But sine and tangent base it on what's on top in the trig formulas. And so that's why cotangent would use 1 and 2. All right. Now let's look at the next page, and we're going to look at one example of 15 through 17. And it really doesn't matter which one I do, but I think I'll do 16 because that might be a little bit more difficult with that addition problem in there.
Yeah, that's I got all of them done except for that one.
Now this starts off the same way the other one did, y'all. Did you realize that? You're drawing the circle. You just don't know if it's positive or negative, so just assume everybody's positive when there's letters. Does that make sense so far? So for arc sine to be x plus 1, I need to put that over 1, so I've got a top and a bottom. Does that make sense so far?
Mhm.
Okay. So this is y and this is r. So my radius to my circle is r equals 1. And my y is x plus 1. So I need to find my x. Now this x is not the same as that x, and that's what's confusing about this.
Yeah.
So if that bothers you, you could make that other x something else, because the x down here relates to the trig. So I've got to do x squared plus x plus 1 squared equals 1 squared. So this y formula is actually a formula related to this x. So I can use x down here, and I can use this, and you can see why I wanted to do this one, because I got to square that out to work the question. So x squared plus x squared, 1 squared is 1, double the middle is 2x, equals 1. If I subtract 1 from both sides, that goes away. Does everybody see that? I've got 2x squared plus 2x equals 0, because the 1's are going to cancel. It's just like if you got the same thing on both sides, you can just drop it. If I take out a 2x, that'll leave me with x plus 1. 2x is going to be equal to 0. Now, hold on, see if I can get that moved up. X equals 0. And x plus 1 is going to make equal to 0, x equals negative 1. Now, let's reason this out for just a minute. So, we have solved for what x can be, but can x be 0, the length of a side? No. So that answer doesn't make any sense. So the other answer, x equals negative 1, is the one we're going to use, because now I know it can't be negative in quadrant 1, but we didn't know if it was going to come out positive or negative, so we just draw them in quadrant 1 and just deal with it. Okay? Even if it comes out the wrong sign for quadrant 1, we just use quadrant 1 because we have no idea where to put it. So now, what was the outside word? Okay. So now we're going to look up cosine of our angle. Cosine is x over r. And since x is negative 1 and r is 1, the answer is negative 1. And so that's how it works with algebra, is you just assume everything's in quadrant 1 to label it so you can see what your x, y, and r's are, but then you do algebra to get your numbers, and your number has to be something besides 0 because it's length. Yeah. Okay. Well, we haven't done much about secant and cotangent, so we'll just do number 17. So in number 17, cotangent of arc secant of x over 3. Now remember, secant is the reciprocal of cosine. So arc cosine would be 3 over x. And that makes that x over r. Does that make sense so far? And I put it in quadrant 1 because I don't know where to put it. So x is equal to 3 and r is equal to x. So I got to find my y. I don't know what y is. And I need y because y is in the formula for cotangent. So 3 squared plus y squared equals x squared. Because you're plugging in x for r. And if you've forgotten, the formula is x squared plus y squared equals r squared when you relate it to a unit circle instead of Pythagorean theorem. With a, b, and c, they use x, y, and r. That's the formula for the circle. So this is going to be 9 plus y squared. Let me, y squared equals x squared. So you're going to solve it for y. So y squared equals x squared minus 9, because you're going to move the 9 to the other side. And then you're going to square root it. Now when you square root it, that puts a plus or minus on it. That makes it plus or minus the square root of x squared minus 9. And really that would give us two different answers for the question. Because cotangent of an angle is x over y. And my x in this problem is a whole number 3, and my y has a plus or minus. So I'm going to get 3 over the square root of x squared minus 9, and negative 3 over the square root of x squared minus 9, because it's plus or minus, and I can't write the plus or minus on the bottom. I need to write it as two separate answers and bring the negative up.
Would 15 be the same way?
Yeah, it'll be something like that, where you've got to solve it for whatever variable you don't have and get an expression.
So it'd be like plus or minus 2.
And with these particular problems, like I said, we don't know if it's positive or negative. So if you get a plus or minus in your problem, you can just write two answers. All right, we're not doing 18, 19, and 20 because we didn't go over arcing. So do we have any problems with the artwork on the back with derivatives? 22.
Yeah.
All right. So in question number 22, I'm guessing that x on the bottom probably shouldn't even be there, as terms of in looking at the question. But well, the problem is this is derivatives, so that makes it quotient rule. And if it was integration, I'd move it to the side and make it part of the du. Does that make sense? But since it's on the bottom, that's quotient rule. And that's going to make it really nasty. Most of these were really straightforward. This was the only one that wasn't, because all the others, you just used a formula. Well, let me phrase that. Number 24 is product rule. All the others, you just used a formula outline. So first, we need to set up our quotient rule, and then we'll come back and fill in the piece that's the derivative of the top. So you write down the denominator, the derivative of the top we'll come back and put in, minus write down the top times the derivative of the bottom, which is 1, all over the bottom square. Does that make sense so far? Now I could square that. I don't know why they didn't, but I could. Won't simplify that much over there if I do, but it could be squared. Now, I don't have my derivative sheet up here. Let's see if there's one missing. Nope. Can you tell me?
Yeah, negative du over 1 plus u squared.
Negative du over 1 plus u squared. Okay. So the formula for cotangent is the same as the formula for, arc cotangent. It's the same as the formula for arctangent, except for that negative. Is that true?
What?
That the arc cotangent and arctangent are almost identical except for the negative?
Mm-hmm.
So it's basic, just doesn't have any square roots in it and all that in terms of the problem. But when I start filling in the information, 1 plus that squared, and it's already squared, means it'll be to the 4th power. Does that make sense? If you square a square, doesn't that make it to the 4th? Because you multiply the powers. And then the derivative of that would bring the 2 in front and make the 3x go to the 1 power, and then it would multiply it by the derivative of the inside, which is 3. Now, you could have done this, and this would have made that part a little easier. Let's see if we get the same answer. You could have squared this first. Does that make sense? Then when I put the 2 in front, that would make negative 18x. Is 2 times 3 times 3 going to make negative 18x? Yeah. So it's just a matter of, did you want to work with chain rule, or did you want to square that out so you could just do power rule? Negative 18 over 1 plus 81x to the 4th.
I think you forgot the x on top.
Oh, thank you. And I'm going to square this out over here. Well, so I was going to square it out, but I didn't. 9x squared. So now that we've got the derivative of the numerator put in, that looks nasty. Ooh-wee. Oh well. So, how do y'all think we need to clean this up? And I'm going to erase or move this DU work. Well, it would help if I did not have my pen in my hand. Get rid of that crazy mark I made. Alright, so what do you think we need to do in order to clean this up?
We distribute x.
Yeah, which makes it go to the top and make that squared over 1 plus 81x to the 4th. Now, this over here is not a fraction. And I'm not saying that I want to get a common denominator here, because that just would make the problem look a lot nastier. But what are we going to do about this division down here? Maybe we could do something with this to clean it up a little bit. How do I divide by that? What does it mean to divide by x squared when you got lots of stuff on top? Right, we can multiply by 1 over x squared. And basically all that's going to do is put an x squared on the bottom of these two. So negative 18x squared, wait a minute. Might do more than that. Yeah, these two cancel. Minus arc cotangent 9x squared over x squared. So in this case, where these two cancel, I end up with negative 18 over this parentheses, and I end up with the fraction over there. And granted, they don't have a common denominator, but that's a better looking answer than if I got one. Does that make sense? Sometimes getting a common denominator is not a good thing. Sometimes just flip and multiply so something can cancel. But you got to remember, flip and multiply to everybody. Each fraction gets it. We good?
Can you get rid of x squared on the other side?
No, because this one's inside of a trig word, so it can't go. But this one over here could, so that was good.
Like if you could just remember the formulas, they're not that bad.
Right.
The formulas are the hard
Right, and they're all similar. You really have to memorize 3 formulas, because the other 3 words just put a negative on it because it starts with a C. So I would suggest just, honing in on what are the big differences between the 3 formulas. And sine and secant, the big difference between those two is there's extra stuff on the outside of secant, right? Where this one is addition, the others are both subtraction, aren't they? The other 2 formulas, sine and secant, aren't they like a square root with subtraction inside?
Yeah.
So there's some subtle differences, and this don't, and like the derivative of this one doesn't have any square root in it because tangent and cotangent don't have square roots in theirs.
And then with this secant, it's u squared minus 1, but sine is 1 minus u squared. So
Right, so it flips. So there are just a few things like that that you probably need to, focus that studying on to make sure that you've got that. All right. So I'm going to stop with that and go back and do a little bit more on word problems today.
So this is all the quiz.
Yeah, the next quiz, yes, I would like to have on that. I have no idea what I did with those notes from yesterday. I hope I stuck them in something that I can find. I think I stuck them in the book. Alright, so yesterday we worked on radioactive decay. So today I would like to focus on I'm trying to keep my notes in order here. the formula that we looked at before about continuous interest, sometimes you don't have everything you need. And we looked at that in the previous work with how do you solve for different things that are missing. Well, in this particular lesson, they go back and they want to focus more on PERT. And so I thought we would pick up there today since we did some stuff with PERT in the last few days. So we're going to focus our attention on our notes today on compound continuously. And this relates to question number 29 in the book. And it's one of them table things, y'all, so I'll just write it out instead of running getting those books right now. We're going to start off with $1,000. And we've got 6% interest. And here are the two things they'd like to know. One, what's the account balance in 10 years? And two, how long to double your money? So in other words, how long will it take before I have $2,000? Does everybody understand what the question is about? Does that make sense to you? So this whole set basically does that. The thing is, they do it in different ways. Sometimes they give you the initial amount. Sometimes they'll give you how long it takes to double. Sometimes they'll give you the amount of money in 10 years. So there's always something that's causing you to have to go back and figure out the problem. But in this problem, because this is related to PERT, the formula doesn't have a C in front of E. It has P for PERT. Does that make sense? That this is similar to that formula where we put the C in front, where C stands for how much you started with, because P is how much I start with. So in this case, I have P, I have R, and those are going to stay the same in all these questions. Does that make sense? In terms of, that's outright what I've got. But T is going to change, and A is going to change depending on what I'm asked for. So to begin with, I have $1,000 for P, because this is how much money I started with. That has to be P. Principal is always how much you start with. And R is going to be 0.06 for 6%, because you always move your decimal over 2 places. Now to get the first answer, that seems pretty easy, doesn't it? I just plug in T, and T will tell me how much money I had after 10 years. But if I don't put that in parentheses, the calculator doesn't do it right. But it's real simple. So if they're wanting how much money you've got at the end of 10 years, then you're not going to have too much trouble filling that information in and getting that answer. Everybody agree with that?
Yeah.
All right. The second question is a little bit more difficult. But once you see it, you'll realize there's a shorter way to do it. So if I start with that same formula again, and I want to double my money, and I want to figure out how long does that take to do that. If I start with $1,000 at 0.06, I don't know how much time. That's what I'm looking for. How long does it take to double my money? Well, how much is double your money? Right, you can double that. Now let's just think this through. This is kind of common sense. 1,000 times 2 makes 2,000, right?
Yes.
So when you're asked to double your money, leave the P all totally out of the formula would make sense, because e to the 0.06t is going to have to be 2. Think that through. 1,000 times that E problem made 2,000. That means the E problem has to come out to 2. Does that make sense?
It's basically like you divided by.
It's right. It's like I divided by the 1,000. So instead of going through all that process of trying to divide by the 1,000 to get the 2, just set the E to the RT power equal to 2 if you want to double. If you're going to do triple, you can set it equal to 3 and so on. All right. Now, to solve that, you have to change it to an LN. So remember, when you do that, you're going to put LN on both sides. So that makes it LN of 2. The E and the LN cancel out, 0.06. And you're going to divide by 0.06 and get you a decimal for how many years it takes. Because years can be a decimal. We can have part of one. Now this one's a little bit more straightforward because I started with the initial amount. So we're going to look at some that don't start with the initial amount here in a minute.
How many decimal places?
3's fine. It's time, it can have 3. How many years did that take?
Like 11 and a half, like 11.552.
Okay. So that's a long time. I don't think I want to leave my money in there that long. I didn't make that much. All right. So now let's take this same kind of scenario with a different set of numbers, but not be given the initial amount. In 31, well, let me phrase that. They may have given you the initial amount. They didn't give you the rate. They started off with $750. I don't know what percent that is. So that's one of the questions I got to figure out. But what I do know is my money will double in T equals 7 3/4 years. And the other thing that they told me is they want me to figure out again how much money I have in 10 years. So what's the account balance after 10 years? Well, in order to figure that out, I have to have R, T, and P, right? And I don't have one of those. I don't have R. So my job will be to figure out what R is with this double problem, because that's the only one they gave me the number for. And then after I figure that out, I can go do the 10. So, again, if you're going to double your money, 2 is going to be equal to the E part of the PERT formula. I don't know R, but I know this is 7.75 for T. Does everybody agree with that? So I don't have to do the whole formula for PERT when I'm looking for doubling. I just do the exponential part of it. Now I'm going to do ln on both sides. So that's going to make ln of 2 equal 7.75R. If I divide by 7.75, unless you just really like mixed numbers, that's going to give me a decimal for the percent. Now we probably might want to keep a little extra decimal places here than what we do sometimes. Maybe let's go for 4 this time. What would that be?
0.0894.
Does everybody agree with that? 0.0894. Okay. So since we're doing 0.0894, that's going to, I didn't have mine out that much, so I wanted to change my answer. That's going to give us 8.94% for R. You do need to change it to a percent because the answer to the question is what percent. Okay? But when you put it back in your formula, you're going to use the 4 decimal place. So now, let's go back and fill our whole formula in to figure out 10 years. How much money did I start with? $750. And I'm going to put that decimal in, 0.0894 times 10 years. And that's going to tell me how much money I have in my account if I start with $750 after 10 years of leaving it there.
That's about 1,833.67.
Okay.
That's pretty good interest rate.
Yeah, that's not bad. You know what I just did? I just changed the answer on the wrong question. I didn't notice that. Oh. I don't know what the answer was. I think it was 9.5.
I like these a lot better.
Yeah, these aren't bad. Money problems are pretty straightforward.
Is it
Alright.
some business calculus?
Yeah, some of it is business calculus, yes. And also, y'all, we could do this problem with, they gave us the 10-year number, and they didn't give us the rate, and we could work it that backwards the same way with not knowing what the rate is. Figure that out, and then come find, like, what it would be for doubling. So I'm only going to do 2 out of the 3 in this set, because there's 3 different scenarios. All right, so the next thing I want to look at, and this was kind of interesting, probably it's better that we weren't looking at the book because the book has typographical error in it. In one place it says it's 1990, in another place it says it's 1900. That's a big difference.
Yeah.
But I believe they meant for it to be 1990. So we're going to talk about population. Population. In these problems, they're going to give you a town and 2 different time periods and what the population was. So, for example, we'll just do question number 41. And that way you've got a sample to look at that relates. This is Detroit, Michigan.
I've been there.
What'd you go there for?
Vacation.
Oh, okay.
I went to Detroit, went to...
Experiencing
It was actually, like, really clean, like where we went.
Right, yeah, that's the problem with Detroit. It's really bad or it's really nice. There's no in
We
between.
went to the Riverwalk, and you can look over and you can see Canada.
Mm-hmm.
Like, you just looked over and we're like, well, there's Canada. I know.
All right, so this is what the problem will kind of be like. It'll tell the name of the city. It will tell the population at 2 different times, and they should both be 1900, 1990, and 2000. So the book's got the typo there. It tells it in the reading the correct date, but it puts it on the table wrong. And they ask for us to predict what it will be in 2010. Now, as you can see, the population's gone down. Well, you know, gang violence, everybody's moving away, jobs are gone. Detroit's used to be big for music and cars. And since we have so many cars being made overseas now, it's a mass exit. So, let's look at that other formula that we learned about to do this question. Y equals CE to the KT. That's the formula you use for anything that you're wanting to see how something grows over time or how it decays over time, which in case this one. Now, your first piece of information that you need to understand about this particular problem is that this is time 0. Now, what does that tell me? If that's t equals 0. Well, yes, that means this is t equals 10, but that wasn't what I was going for, but thank you, because I would have got to that in a minute. But that wasn't what I was going for. I meant, what part of the formula does that help you to fill in? That's your starting value, yes. So I now know that this is 3. Does that make sense? I got one number without doing any math. What you gave me, Jacob, this 10, is going to help me to fill in t and y so I can solve for k. So I did need that. 2.74 is going to be equal to 3e to the k times 10. Now I need to divide that 3 first before I do the ln thing, because that just makes the math a lot easier. So 2.74 divided by 3 is going to be equal to e to the 10k. Now, to be honest, y'all, I don't divide that and write it down on my paper. I just leave it that fraction and get the problem all set up and then just put it in the calculator and let it give it to me all at once. So I do my ln on both sides so that my 2.74 with the ln is a fraction. And over here I get 10k, so I can divide by 10. Now, it might be easier to type 1/10 in there. because you know how your calculator's kind of funny about fractions? So it might be easier to say 1/10 and flip multiply than it would be to divide by 10. And so we're looking for K, trying to get a decimal value for the rate at which it's changing by. Because that's what K stands for. It's a rate. Just like R is a rate in those other formulas, this is the constant of variation. It's how much the rate is changing by.
I got .0091.
That's what I got.
Yes, that's the correct answer. And negative means that it was going down. Well, we saw that already. And the .0091 means it's going down kind of slow. Well, yeah, it means it's going down kind of slow. But we're talking about millions of people, so that's not really slow.
Yeah.
And then, of course, this will be t equals 20 is what we're looking for. So we go back and we fill in everything now, so that we can find out what it will be in 2010. Trying to figure out what do I need to cover today. I might do one more problem. 2.5 million? Okay. Might want to keep an extra decimal because this one had 2. Normally millions doesn't keep but 1, but if they keep 2, you should keep 2.
Well, it was .5008.
Okay, well then keep the 0. Don't drop it, like when you write on your paper. Because you should always look at your numbers and see how did they round them and kind of round the same. But most of the time when you talk about millions and trillions, people only usually put 1. I was really surprised they put 2. All right, the next thing we're going to look at okay, let's see here. I'm trying to pick questions that are similar to each other as much as the stuff we've been looking at. Oh, that page of notes definitely does not go with this page. I don't know what page this went with. It doesn't go with this one because I got 257s. All right, I think that I might just stop because let me explain what I've got left. I've got an atmospheric pressure problem, a forestry problem where the formulas are already given to you. We're going to look at an earthquake problem, a sound problem, and Newton's cooling. So that's quite a bit. So that gives me 1, 2, 3, 4, maybe 5 questions left for tomorrow, or whenever we get to it. All right, so we're taking the quiz tomorrow on 5-8, but let me go ahead and assign that just a handful of problems to go with last night's homework, because there aren't many of these. So this is on page 364. So we did the radioactive yesterday. So today, I want you to do 30 through 34. And then I want you to skip down and do 40 through 42. And I skipped a few in there that didn't relate to E, that related to that other formula that has the compounded daily, monthly, or weekly, because it doesn't relate to E. I was trying to stick to what relates to E in this particular thing. Alright, so now, we know that we've got a quiz tomorrow on 5-8, and it will be nowhere near as long as the worksheet.
Right, good.
Okay, that was the original quiz I used to give for this lesson, but they didn't have a worksheet. Or if they did, I lost my worksheet. So what I'm going to do is try to give you maybe, on some of the sets, maybe a couple of questions, and on maybe some of them just one. Like the first set where you got to know the unit circle, I might give a couple, or maybe 3. And then the second set we're doing on the calculator, I might give a couple. And then the third set where I give you the fraction with numbers and ask you to draw the circle and come up with a different trig, I'll give 1. And then the fourth set where we had the algebra, x's and stuff were in there doing the same thing, I'll probably only give 1. And then might be a little bit more with derivatives, maybe 3, so you could have 1 of each formula. Let me phrase that. I know there's 6 formulas, but 2 of them are alike.
Yeah.
So you'll have 1 of each trig set, whether it's positive or negative, you'll have to figure out because it starts with a C. So that's what I was hoping to do with that. Now, with, I'm trying to find what it is here. With our next test, let's see here. You'll have some stuff from section 9. Okay. I probably need to come up with some problems for y'all for section 9 where you can practice some integration problems, because I don't have a worksheet on that. And maybe that's what some people can work on tomorrow after they finish the quiz while they're waiting for others to finish. And then we'll try to check the homework, and I don't know if I'll have time tomorrow for the other 5 questions from the word problems that I need to do. But if we don't have time for that, then I won't start it. I'll just wait and do it Monday and let you just work on that worksheet. It's not going to be as long as that one. It'll probably be less than 10 questions at the most, and that's if I can come up with that many. Because these aren't easy to make up in your head. So tomorrow we'll take our quiz on 5-8. We'll have a worksheet on 5-9. If there's a lot of time, we'll do notes on those last 5 questions. If there's not a long time, we'll just spend the rest of the time on 5-9. That looks like that will put our test probably Wednesday of next week on this. Even if I go back and start reviewing chapter 6 in the meantime, it looks like that's what it'll do.
So how many more quizzes and tests are we going to have?
I would like to have at least 1 more quiz after tomorrow and 1 more test and a project, if I can get it in.
So 2 tests, like this test that we're going to take.
If I can. If not, then we'll have a project, definitely. Because I'll just cut my losses and go straight to the project. So after we get this test in, I'll be able to tell how many days I have left. And if I don't have enough time, then we'll go straight to the project. So I want y'all to be able to do the project because it's fun compared to taking tests and quizzes. Okay. All right. Everybody good?
So I have a question.
Mm-hmm.
So cosine is quadrant 1 and 2.
Mm-hmm. And so is cotangent, because tangent has cosine on the top of its formula.
Right. Okay. And it's x over r.
Mm-hmm.
What's
Okay.
it?
No, cosine is. Cosine's x over r. Mm-hmm.
Okay, so what's cotangent?
Cotangent is x over y.
Okay. And
And that's why they both use quadrant 1 and 2, because x is on top, and that's because x's are positive in one of those quadrants and negative in the other. And see, sine is y over r,
yeah.
and that's why it uses 1 and 4, because that makes it change sign from positive to negative.
Okay.
And then tangent is y over x, and since y is on top, it uses the same thing sine does, because it's all about sine over cosine.
Okay.
And those formulas are on the formula sheet that you have that has the unit circle up in the corner, in case you need to look over it more.